Okay, so we have the next topic, next and last topic, which is the kinetic molecular theory for gases. So we have here the formulas: RMS velocity, VRM is equal to also U is equal to the square root of 3 RT. So this should be in meter per second. So we already know that R is a specific gas constant, so that can also be represented as 1000 R all over the molecular weight. So R is just the constant number 27. And then for the T, that is the temperature. So if you want to find the Kelvin in Kelvin, Celsius plus 273 equal to the Kelvin, and then run and the conversion to Rankine and to Kelvin, given Kelvin or Fahrenheit, etc. So this is just a conversion of temperature. So for the can also have this formula, which is equal to the square root of 3000 times constant number 27, that is actually the R, times the temperature in Kelvin all over the molecular weight. Remember that in this one, the if you're using this formula, the gases or the element should usually is in free state. Okay, so if you say free state, I will discuss it later on the problem. So for the number 2 average velocity, that is just 0.921 of the DRMS, and then for the average kinetic energy of a molecule, that is just the kinetic energy is equal to 1 half mv squared, but the velocity should be the um, root mean squared or RMS, or equal to 1.5 k t, where k is the Boltzmann's constant number 25 if you are using the Casio 991 ES plus, and then t is still your temperature. So with that, let's move on to the first problem. For the first problem, we have what is the RMS velocity of oxygen at 70 degree Fahrenheit. Okay, so for this one, we have given again. There is actually a fun way or mnemonics for this one. Okay, I will discuss it again later on. So we have here T is equal to 70 Fahrenheit. This is oxygen. No, this is oxygen. Remember that this oxygen is in free state. What you mean by free state? Free state is that this oxygen is not associated or there's no activity on this one. It doesn't have any activity or it's not associated with any other elements. So therefore this oxygen is in free state. Therefore, you have to consider that oxygen is a diatomic element. When you say diatomic element by the means of di, that means that whatever the molecular weight of the element, you have to multiply it by 2. So oxygen is a one of the diatomic elements. So what happens here, since the molecular weight of O2. So this one, therefore, that must be 16 times 2. Therefore, the molecular weight of this one is 32 gram per mole. So here are a fun way to memorize the elements that are diatomic elements. So it's actually H, um, N, F, O, I, C. So what happens here is this is my mnemonic here. So have no fear in ice cold beer. So you have your H, N, F, I. This is not I. Sorry. Should be not I. It should be O. O, I, C, and B. For that, we have hydrogen, of course. Hydrogen. Okay. Nitrogen. F is for fluorine. And O is for oxygen. Oxygen. I is for iodine. Iodine. And then I think C is for chlorine. Okay, this is for chlorine, not carbon. Okay. Don't be confused with that. And then B is bromine. No, should be bromine. So these are the elements that are diatomic. Okay? Diatomic elements. Diatomic elements. Have no fear on ice cold here. Okay? So let's continue. Let me just extend this one. So using the formula, which is the VRMS is equal to the square root of 3000 R, right? R, or the constant 27 times K. So that is the temperature and the molecular weight. So we have a given of 70 Fahrenheit, diba? Therefore, T is equal to 70 Fahrenheit. So all you have to do is just convert this into Kelvin. So T must be equal to 70 in Fahrenheit plus 460. Okay, that will be in Rankine, and then dividing it to 1.8 will give you in Kelvin. So this is 295 Kelvin. And then VRMS now is equal to the square root of 3000 R, or the constant number 27. No, constant number, yeah, constant number 27. And then times this by the 295 all over the molecular weight is 32, since oxygen is a diatomic element. So using your calcu, the answer for this one is just equal to 479.53 meter per meter per. That's it. Okay, so we have for the number 2 is what is the average velocity of nitrogen molecule as 20 degrees, or that is the temperature. So for the given, we have nitrogen, right? Nitrogen. So this is N2. Therefore, you can say that the molecular weight of nitrogen should be times 2. So 2 times 14. Okay, so this is equal to 20. Okay. So, and then we also have the temperature, which is equal to 20 degrees Celsius. So plus 273. So this will make it in Kelvin. So 293 Kelvin. And then we are required to find V average. So for the solution for this one, so you can see, this is just the average velocity is just equal to 0.921 of the uh, VRMS, right? RMS. Therefore, I can also rewrite this as 0.921 square root of 3000 R Kelvin, right? All over the molecular weight. So this is equal to 0.921. Okay. Constant number 27 for R. That is 3000 R times K is 293, right? That's given. All you have to do is just convert it into Kelvin. And then for the molecular weight of nitrogen is 14. But since that is a diatomic, so that is 2 times 14. So 28. And then, therefore, using your calcu, the average velocity will just be 478.54 meter per second. It should be 7. So as you can see, nitrogen is here. Nitrogen. So let's move on to the next number. So let's have the number 3 and the last number, which is the what is the average kinetic energy of gas molecule at 0 Fahrenheit. Okay. So we have here given is just the temperature in 0 Fahrenheit. But this should be in Kelvin. So this is just equal to 0 Fahrenheit plus 460 to make it in Rankine, and then divide it to 1.8 to make it in Kelvin. So this is 256 Kelvin. Okay? And then for the solution, all you have to do is to use the formula, which is the kinetic energy is just 1.5 of the K T. So this is equal to 1.5, where K is your Boltzmann constant, that is constant number. Okay, so this is in the principle. Constant number 25. Number 25 times the temperature, 256 Kelvin. Therefore, your Ke, or the average kinetic energy, is just 5.3 times 10 raised to negative 21 joule per molecule. Okay, so that will be the unit for this. And this will be your answer. So I think that's the end of the series of this video. So I hope you guys learned something, and I was able to help you, especially during this pandemic or online classes. So again, if you have any questions regarding the problems, all you have to do is just leave a comment down below, and of course, don't forget to like my videos and subscribe to my YouTube channel. So with that, I want to thank you all guys for watching, and I'll see you on the next one. Bye bye.